Namaste student, this is Sanjay Nath. Today's session is on Structure of the Earth's Interior, Chapter 4, ICSE Standard 9. In this chapter, we'll understand the realms of the Earth, different layers and their characteristics features. Before we understand the inside of the Earth and the interior structure of the Earth, we'll look at the birth and the evolution of the universe. About 14 billion years ago, the universe was created in a huge explosion that scientists call the Big Bang. The Big Bang was so enormous, the particles scattered into the vast universe. Immediately after the Big Bang, the universe was very hot and dense and filled with energy. As universe expanded, the temperature began to fall and the first particles of matter formed from the energy. After more than 1 billion years, the first stars and galaxies had formed, the solar system including our Sun and Earth. Now we'll understand the solar nebular hypothesis. The solar nebula hypothesis describes the formation of solar system from a nebula. A nebula cloud made from a collection of dust and gases. According to the theory, about 5 billion years ago, the Sun was a protostar and a huge fast-moving nebula happened to brush past it. Due to gravity of nebula, some part of the Sun was scraped off. Initial motion given to the planetary matter was now controlled by the gravity of the Sun. As you can see, these particles are revolving about the primitive Sun. These are meteors, meteorites and large asteroids. In the course of time, they grew bigger by colliding to each other, because of which the material started revolving around the primitive Sun. They also gained gravity. Because of the revolution of the planetary material around the Sun, there was a churning effect resulting in the assertion, where large and big meteors they combined to form the early planetoids. Among them, this molten Earth. The large mass of dust particles and tiny planetary matter followed the nebula and the dust particles suspended in the space. Now we'll understand how the Earth is evolved, or the birth of Earth. Due to continuous assertion, the meteors grew larger in size, as you can see in this video clip. The early Earth, molten, flickering, large meteors and asteroid bumped on Earth. Several meteors got together and formed the early asteroids, among them this molten Earth. As the asteroids were attracted towards each other due to gravity, they collapsed into form the early planetoids. The early Earth was molten and attracted more particles from the surrounding and began to grow bigger and bigger. In the course of time, Earth started cooling down from outside to inside and has given birth to the present Earth that's surrounded with a thick atmosphere and vast ocean. After the process of assertion, the molten Earth started cooling down from outside to inside, the process of differentiation. In this process, the early Earth, about 4.5 billion years ago, started cooling down. Outer layer became the solid crust and the process of cooling started. This was due to the sudden stop of falling of meteors and asteroids. Heavier material sank towards the core, mainly nickel and ferrous, and in the course of the time the core grew bigger and bigger, and molten material got trapped in the mantle between the crust and the core. This was the beginning of formation of layers of the Earth. After the formation of the early Earth, the cooling process developed the upper crust, followed by different layers inside the Earth. But the big question still exists: how to determine the density and thickness of the different layers of the Earth. Numerous attempts was made in the past to understand the inside of the Earth. Verification of this assumption is very difficult because of the diameter of the Earth is more than 12,000 kilometers. Till date, the deepest hole dug on Earth is about 16 kilometers. Now you can understand how difficult it is to understand what is inside the earth. Hence, direct method cannot be used to find out about the interior of the earth. The only way to explore the inside of the earth are as follows: temperature anomaly, density of the rocks and minerals, geostatic pressure, and seismic waves. Now we'll understand each one in detail. Indirect methods. Temperature anomaly inside the earth. As you can see, the internal heat inside the earth increase tremendously. The red line shows the increase in temperature due to increase in depth. At the depth of more than 5,000 meters inside the earth, the temperature increased rapidly. The temperature rose up to 6,000 degrees Celsius. Now this internal study of the earth with the help of certain technique, it reveals that inside the earth the temperature is too high. One of the very significant reason behind the heat anomaly is the convection currents. This is called the mantle convection. From the outer core, the heat that radiate or heat that passes from the core towards the earth crust, it generates internal heat in the process. Now we'll understand how to determine the density and thickness of the different layers of the earth. This is another very important indirect method with the study of density of rocks and minerals that present inside the earth. Now you might be thinking, how could it be possible to know that what would be the density of different rocks and mineral? How could it be possible to determine the density of the rocks and mineral that is inside the earth? Yes, it is possible. As you know that earth is in the constant process of change. On the earth crust there are many cracks and faults are there, or vents are there, through which the magma that comes out and solidify in the form of different types of rocks. Now these rocks that solidify from the molten material that is exists inside the earth, it gives a proof or evidence of what would be the chemical characteristics and the density of the material that is inside the earth. Now as you can see, this graph shows there is a difference in density material that exists. This line that goes deep inside the earth from the crust into the mantle, and there is a consistency, and the boundary between the mantle and outer core, there's a drop, and again there is an abrupt drop till the center of the earth, the core. Now if you see the crust, the graph represents that the density of the rock is less than 3 gram per cubic centimeter. If you go further, now if you now go deep inside the earth, the density of the rock will increase 6 gram per cubic centimeter. Now near the boundary of the mantle and the core, there is an increase in the density of the rocks is somewhere plus 10 gram per cubic centimeter. Between the outer core and the inner core, there is a drastic change in the density of the rock. It increases till 13 to 15 gram per cubic centimeter. In this manner, one can determine the density of the rocks and minerals and make an assumption about the inner core, outer core, and the mantle made up of different types of rock, or they are made up of different density of rocks. As you know that earth is differentiated into different layers, but how can you determine that? Crust, mantle, and core. A recent study says that the J waves, this is a visual of J waves that travel inside the earth, and different locations it has been recorded that the J waves strike to the core and return, and in this manner we can determine that inner core, it behaves like a solid. Now why it behaves like a solid? The recent studies say that in spite of 6,000 degree temperature inside the core, it behaves like a solid due to the lithostatic pressure. The pressure of crust, mantle, all together on core. The outer core is molten, inner core radiates a lot of heat that keeps the outer core in the molten state. Now how to determine the density and thickness of the different layers? The fourth important and significant indirect method is use of seismic waves. Among all the methods like temperature anomaly, geostatic pressure, density of rocks and mineral, this particular method became very significant. We therefore have to rely upon the result obtained from the study of behavior of seismic waves inside the earth. Now first understand what are waves. Waves are the series of disturbances caused in the particles of any medium due to the propagation of energy. Now, seismic waves are generated due to the release of seismic energy during an earthquake. Now, this could be also generated with the help of artificial means using any explosion. Now, scientists use this knowledge. With the help of this technique, they manage to determine or assume the interior of the earth and differentiate different layers. Now we'll understand with the help of a video clip the how seismic waves has been used to determine the interior of the earth. Here the seismic wave behavior is very important. There are two types of seismic waves has been used, P waves and S waves. P waves travel through all medium and S wave travel through only solid medium. As you can see in this animation, the P waves have been traveling towards all direction. It is shown in blue and green color. The propagation of P waves behave differently in different medium. As you can see, it is bent and reflected because of change in the medium. Now, the speed or propagation of the waves has been recorded at different recording stations, and with the help of complex method, one can calculate the thickness of different layers. Now, we'll understand how seismic waves behave inside the earth with the help of this diagram. As you can see, at one point, artificial explosion has been triggered, and these blue lines showing the path of P waves. At these points it gets deflected because change in medium, but it has been recorded on the other side on different earth station. Whereas the S waves travel differently, it gets deflected from the outer core because it cannot penetrate inside the liquid medium. The scientists assume that the interior of the earth at this level will vary, and with the help of some calculation they can determine the thickness of different layers. Now we'll understand the behavior of seismic waves, P and S waves. These P waves are also called the longitudinal waves. They are the fastest traveling waves and arrives at all the station first. It can travel through solids and liquids, both the medium. Below is S waves. These are also called the transverse waves. It is slower than the P waves, arrives at all the station second, means after P waves reach. It can travel through solid only. The more destructive of all the waves are S waves. Vibrations are at the right angle to the direction of the wave. As you can see the propagation, this is forming a crease in the throat that cause more damage on the earth crust at the time of earthquake. Now to understand the characteristics features of seismic waves. There are four kinds of waves are there: P waves or primary waves, S waves or secondary waves, low waves and Rayleigh waves. Out of these four waves, P and S waves are provide maximum information about the Earth's interior. This following table, it says everything about the P waves and S waves characteristics. Now P waves are compressional waves and longitudinal. S waves are shear or transverse. Waves travel in compression or rarefaction, and S waves travel in crest and throats. As you can see in this diagram, this is the crest and this is the throat. Particle movement is back and forth, P waves, and S waves travel up and down perpendicular to the direction of propagation. Speed of P waves is fast and speed of S wave is slow. Because S wave propagates slow, it causes more destruction, whereas P waves cause less destruction. P waves travel through all medium, S wave only travel through solid. Now understand the layers of Earth based on the several such experiments. The thickness of continental crust is 70 to 80 km, while the thickness of oceanic crust is 10 to 20 km. On an average, the continental and oceanic crust, if we combine, the average thickness will come to 60 km. Followed by that, the next layer is mantle. It extends at the depth of 2900 km. After that, outer core till 5100 km, and inner core is approximately 6500 km. The properties of the Earth's interior are summarized in the following table. This is a very important table. As you can see, the thickness of crust, mantle and outer core and inner core. The physical state of crust is solid, mantle is molten, and outer core is liquid, and inner core is solid. Inner core is solid due to the lithostatic pressure. The temperature is the highest recorded in inner core. In spite of high temperature, inner core behaves like a solid. Density of crust is the least one, it is 2 to 2.5, and density of inner core the highest, 10 to 14 gram cubic centimeter. These are the primary rocks present on the crust. These are the minerals and these are the elements. These are the primary rocks in mantle, minerals and the elements. Outer core contain iron and nickel, inner core contain iron and nickel. Now we'll understand what is the composition of the crust, mantle and core. Crust is made up of silica and aluminium and average thickness is 60 kilometers. Now we'll understand what are the other elements present on earth crust. Oxygen 46%, silicon 28%, followed by aluminium 8%. These are the primary elements present on earth crust. Continental crust is thicker than the oceanic crust. Oceanic crust is primarily composed of silicon and magnesium. Now we'll learn about the next layer called mantle. Mantle is just below the crust. The Earth's mantle is the thickest layer of the planet and accounts for 84% of the Earth's volume and 67% of its mass. It lies between the crust and the core. This is the crust and the outer core. Mantle is divided into two parts, outer mantle and inner mantle. Between crust and the core, the mantle extends up to 2,900 km. Mantle begins at the boundary called the Morovicic discontinuity. It is a layer between the crust and the mantle. Just below the crust or just between the crust and the mantle, there is a plastic layer called asthenosphere. All the continent rest on this layer. The mantle is denser than the crust and is much less dense than the earth core. Primarily, mantle is made up of magnesium. It is more dense than the aluminium present on the earth crust. Now we learn about the innermost layer of the earth is called core. The core of the earth thought to be made up of mostly two elements, iron and nickel. Iron and nickel considered to be the more dense element is the highest density range between 10 to 14 gram cubic centimeter. The core mantle boundary, which is also called the Gutenberg discontinuity. As you can see this diagram, where the mantle ends and the outer core starts, that boundary is called the Gutenberg discontinuity. The outer core is in the liquid form and inner core is in the solid form due to the lithostatic pressure. Due to intense temperature that radiates from the inner core and relatively less pressure keeps the outer core in the liquid state. This keeps the mantle also in the molten state that feeds the earth crust with magma and give birth to volcanic activities. Thank you for watching the presentation.